Good morning, children. Today's topic is reflection in the light. You see in the diagram, you have already been studied in the previous classes, reflection chapter. So for light, mainly there are two types of the medium, rarer medium, denser medium. We define the rarer medium, the medium in which velocity of the light is 3 multiplied 10 to the power 8 meter per second. That is known as rarer medium, and it is air or vapor. And the denser medium, we can define the medium in which velocity of the light is less than 3 multiplied 10 to the power 8 meter per second. All those transparent media through which light can travel, like water, glass, diamond, etc., these all are known as denser medium. You see in the diagram, I have written here small a, that is rarer medium, small b, this is the denser medium. You see in the diagram, the ray of light, see the arrow, the ray of light is coming from rarer medium to denser medium because the topic is reflection. So PO is known as incident ray and OQ is known as reflected ray. Incident ray, reflected ray. N dash is the normal. Normal is generally it is an imaginary line and it is indicated drawing the broken line. We draw the normal for our convenience to locate the path of the light when the ray of the light passes from one medium to another medium. Angle made by the incident ray along with the normal, that is known as angle of incidence, and angle made by reflected ray along with the normal, this is R, that is known as angle of reflection, and I is the known as angle of incidence. Topic is reflection. You see in the diagram, when the ray of light passes from rarer medium to denser medium, it is bending towards the normal. Reflection is a phenomenon. It is a phenomenon when the ray of light passes from one medium to another medium, it deviates from its original path. Either it will bend towards the normal or it will be away from the normal. This phenomenon is known as reflection. You see in this diagram, the reflected ray is bending towards the normal. It may be also possible that if the ray of light is passing from one denser medium to another denser medium, or more denser medium to less denser medium, then it will bend away from the normal. So this is also known as reflection, or simply in one line you can define that bending of light by the ray of light passing from one medium to another medium, either towards the normal or away from the normal. This is known as reflection. Now, law of reflection, second point. Law of reflection. First point for the law of reflection is similar as law of reflection. Incident ray, reflected ray, normal, angle of incidence, these all lie in a same plane. And second, sine angle of incidence to the sine angle of reflection, it bears a constant ratio which is indicated by mu. Mu is also known as reflective index. So these are 2 points for the law of reflection. In this case, we can write down A mu B. A mu B means the ray of light is passing from medium A to medium B, and it's another meaning that reflective index of B, medium B with respect to the medium A. Second question, children, arises here. Cause of reflection. Cause of reflection only due to changing into the speed of the light. The light either bend towards the normal or it bend away from the normal. So only due to changing into the speed of the light. When the ray of light passes from one medium to another medium, either rarer to denser or one denser medium to another denser medium. In both the cases, the speed of the light changes. This is the basically reason that the ray of light deviates from its original path, and this is only the cause of the reflection. Children, now another topic is refractive index. Refractive index, you can define the refractive index. There are only three definitions of the refractive index. Number one, sin I by sin R. It is a ratio of the sine angle of incidence to sine angle of reflection. Second, with respect to the speed of the light, a speed of the light in air to the speed of the light in a given medium. A speed of the light in air to the speed of the light in given medium. And third, real depth by apparent depth. About this definition we will discuss later on. You see here that in all these three types, refractive index is defined in the form of the ratios. So sometimes question arises, children, why refractive index has no any unit? The reason is refractive index is defined in the form of the ratio, so numerator and the denominator both having same unit, and the unit will be cancelled out, and this is why it has no unit. So if the question arises that define refractive index with respect to the speed of the light, only you can write down this definition. It is ratio of the speed of the light in the air to the speed of the light in the given medium. Now, second topic, children, factors affecting the refractive index. Factors affecting refractive index. You see in the diagram, mainly there are number one, nature of the medium. Second, temperature. And third, wavelength. Of rays. So these are three factors which affect the refractive index. Factors affecting the refractive index. Nature of the medium means density of the medium. If the medium having more density, then the speed of the light will decrease. And see the definition of the refractive index. And the refractive index will be more, and it's vice versa. Temperature. If the temperature of the medium increases, the speed of the light will also increase in that particular medium. And again you see the definition. Using this definition, if the speed of the light increases, the value of this ratio will decrease and the refractive index decreases. And third, wavelength of the rays. All of you know that there are 7 visible rays: violet, indigo, blue, green, yellow, orange, red. Violet having least wavelength and red having maximum wavelength. So if the wavelength of the ray increases, refractive index decreases. If the wavelength of the ray decreases, refractive index decreases. This is why wavelength completely affect the speed of the light in a particular medium. Although all the rays, 7 colors rays, having same speed in the air, but in the different medium, denser medium, they are having different speed, and this is why refractive index of violet is greater than refractive index of red, because for a particular medium, if different rays are passing, then it will show different refractive index, because violet will show the maximum refractive index and red will show the minimum refractive index, because the speed of the red in a particular denser medium is more rather than the violet. Children, later on we will discuss about another topic.